Good morning. Eamon Darcy is my name, and I'm the tutor and author of the Magic of Quantum Computing for 9 to 15-year-olds course, which is being run by the Angel School in the UK, in London actually. On the 25th, as you can see in your top left-hand screen, on the 25th of July, at 10 o'clock in the morning for London, 5 o'clock in the afternoon for Perth, I'll be going over a deep dive into the course, but I just wanted to give you a preview so you can see why it's so important to get your 9 to 15-year-old involved with quantum computing. The time to learn it is now. All the large organizations accept that quantum computing is the future. And the good thing is, young people get quantum physics. They love it. They're beginning to know, thanks to the Big Bang Theory, things like quantum entanglement and superposition, making my life a little bit easier. But really, the course starts on August the 25th. All the links will be provided to you. But really, come along on the 25th of July and just see what's involved. You won't be disappointed. So here's the Angel School, as I say, in London. And if you want to check out a bit more about what I'm about and what I've done, you can look at my quantum portfolio at www.quekwa.org.au. I'd like to personally thank Natalie Bourne-Moses, the founder of the Angel School. We've been organizing this for about a year, and it's very exciting. 25th of July, we're going to go through what the course entails. A month later, on the 25th of August, the course starts. Again, really encourage you to get involved. A lot of hard work has been put into getting this ready. As I say, it's one of 3 courses, the magic of quantum computing, the magic of quantum physics, the magic of quantum consciousness. And there's a 4th course underway now, which is quantum teleportation, which is very interesting as well, of course. Amazing stuff. So, to understand the potential of quantum computing, you really just need to look at the websites of IBM, Google, Microsoft, Amazon, Alibaba, and the list goes on. It really does. They are all focused and all looking for people knowledgeable in quantum computing. Quantum supremacy, which is where a quantum computer outperforms a classical computer, has already been done. The time to learn about quantum computing is now. So let me take you through the course and how it's set up in 2 ways. Firstly, the educational methods I use, and then the course content itself. Okay, I have these cards all the way through the courses, which are great. What we recommend from the beginning is that each student has a mentor. Now, this can be the parents. I actually love it to be the grandparents. I know I have a 12-year-old and I'm always tutoring and mentoring her. And I think grandparents make an ideal mentor or even a very good friend of the family. But here I have these cards and they'll come up with important points. And these cards are for the mentor, to stimulate the mentor. Because I'll say something, this is an important point, and the mentor immediately knows to make sure that the student understands it. And then you have games and exercises and discussions and projects. It really helps the student to get ahead with a mentor. Trust me on this one. I use a lot of stories and graphics. Now, one of the hardest things to understand is quantum superposition. You see, when scientists first developed the technology to look inside of an atom, they were absolutely amazed at what happened, because these Subatomic particles, a quantum particle is just, quantum is anything smaller than an atom. But these quantum particles didn't behave in the same way that atomic particles did. They had all of these strange things that experiments couldn't follow. And one of these things is superposition. It means that a subatomic particle, before it's observed, is like everywhere at once. It has a probability wave function of being somewhere between 1 and 0. And it's difficult to get over that concept, and I do that with stories, analogies, and easy to follow diagrams. And I do a quantum earth and a classical earth, and hopefully the student will be able to follow along with that. With every single chapter, I put in YouTube links so that the student and a keen student can do further research. And all of these links have been checked and double checked to make sure they're suitable, relevant, interesting, and engaging. And then there's also a quiz, an easy to use short fun quiz at the end of every chapter. And it just again is a fun way for the student to learn. Okay, so now I'm going to talk about the course content. And the first thing I want to say is that it is very extensive. The 9 to 15-year-old student on completing this course will have a really eclectic knowledge of the quantum sector. So I talk about the 6 chapters, 6 sections of the course. An introduction to quantum physics, because you need to know that before you can apply quantum physics to quantum computing. Then an intro to quantum computing, followed by how do they work. Then section 4 is quantum gates and algorithms, the really fun part. And then believe it or not, section 5, I'll be registering the students and enrolling them on the IBM Q experience, which means that they'll be actually programming a real quantum computer, costing millions of dollars, thanks to IBM. So, yeah, that section 5 will take you through that. And then section 6, we've got the various different technologies, because it's not like a supercomputer or any computer today that basically they all work the same way. With quantum computers, we have different electrons, photons. Basically, any subatomic particle can be used in a quantum computer, and we're not sure yet which is the best. So let's talk about chapter 1 and 2. If we look at the extreme right, we can see an introduction to quantum physics. And you need to know that the amount of people I talk to in the industry who have no knowledge of quantum physics, they just saw the quantum computing as an extension of current computing, which it is, and it's completely different. You really need to have a bit of knowledge on the basics of quantum physics. So I go over what it is, I go over superposition, quantum entanglement, and quantum tunneling. So I go over an awful lot in the first 2 weeks. By the way, each chapter or section is 2 weeks of lectures. And then I have questions and a quiz on that. But it is important to understand the underlying physics. All quantum computing is the implementation of quantum physics to do quantum computations. So on the second chapter is an intro to quantum computing. So what is a quantum computer? And remember, a quantum computer actually uses a thing called qubits, which are just subatomic particles. So it's not like in supercomputers where you have an actual transistor. So you've got physical matter. in quantum computing, the actual computations are done by something a million, billion times smaller than a speck of dust. It can even be done on a ray of light, a photon. So it's amazing stuff. How do they do the mathematics? Well, it's basically through quantum superpositioning, but I explain all of that. And then I go over what is linear algebra. In order to manipulate the superposition, you see, in every other computer, supercomputer or any personal computer today, it's either on or off. The transistor is either has voltage or it doesn't, and it represents 1 or 0. Whereas a quantum computer, a qubit or a subatomic particle, can have this whole host of references in superposition. And that's how it does all its computations. So it's pretty amazing. And then we talk about how do quantum computers work, what is a qubit, and how do multiple qubits work together, because of superposition, we can do millions and millions of calculations at once. But then, believe it or not, by quantum entangling it with another qubit, we get a multi-dimensional space that we can reference to. And that's why it's just simply amazing. It's a quantum computer is exponential, whereas a supercomputer or a digital computer is linear. And the differences between that are just amazing. And I explain all of them. I also talk about the block sphere. And the block sphere is a three-dimensional representation of how superposition works and how you can map and reference to different spots, locations on the block sphere. Once you understand the block sphere, you understand quantum physics, basically, quantum computing. And then I talk about quantum gates. They are merely matrices, so you will have learnt about matrices in linear algebra. And then a quantum gate merely enforces a transition from one location in the block sphere to another, so that you can do a trail of computations along the block sphere. And then I talk about what an algorithm is, which is just basically a set of quantum gates. And then, as I say, if you look on the right-hand side, I program a real quantum computer. So we'll register you. We will then introduce you to how you can use it, and through the quantum cloud, and through what's called the IBM Q experience, which has been available for 3 or 4 years now, you can actually begin writing your own quantum gates. And let me tell you, if you're doing that between the age of 9 and 15, you have a wonderful future ahead of you. I then talk about in the final section, I talk about the technologies. And this is really important because all digital computers work the same way. The voltage is on or off. But in quantum computers, it's totally different. We can use any quantum particle, like a photon, an electron. We can even use a muon, a taion, all those things, proton and neutron. But the jury is out in what is the best technology. You've got superconducting, trapped ion, photonics, and these are just doing amazing computations at the moment. And then I talk about what achievements quantum computing has made and what it will make in the future, in the lifetime of these young students. So it really is very, very exciting. Again, all the links are in the description to this video. And again, please join us on Sunday, the 25th of July, where I'll be answering questions. I'll go over the course again in more detail and answer any questions you have. It will be coming from the Angel School in London. and I'll be speaking and taking you through that. You've also got the link to register, and you've got the link to enroll. So please, on behalf of your 9 to 15-year-old students, let's get them enrolled, let's get them involved, and let's secure for them a highly professional, highly paid, challenging career in quantum computing. Thank you very much.